An AI assistant reads a support ticket, finds a hidden instruction inside it, and tries to send an internal file through a connected tool. The model did not break encryption. It followed context across a trust boundary. In this video, we will build that exact scenario safely, stop it, and turn the fix into a practical MCP security checklist. By the end, you will know how to review an MCP server before connecting it, how to limit what each tool can do, and where human approval belongs. The memorable rule is simple. Treat model output as a request, never as authorization. We will use a fictional local help desk lab with synthetic data and no external systems. MCP standardizes how an AI host discovers and calls tools exposed by a server. The host may hold the conversation. A client maintains the connection. The server describes tools and accepts structured requests. Behind each tool sits a real capability: reading files, querying a database, opening a ticket, or calling a cloud API. Security depends on every boundary around that capability, not on a reassuring tool name. Before installation, ask 5 questions. Who controls the server and its updates? Which identity does it run as? What files, network destinations, and APIs can it reach? Which data enters the model context or logs? Finally, what is the worst allowed action if the model is manipulated? A read-only documentation search and an unrestricted shell are not equivalent integrations. Our isolated lab contains synthetic tickets for a fictional company. The first tool searches ticket text. The second exports a case summary into a local outbox. There are no credentials, customer records, live endpoints, or network calls. At first, both tools are exposed to the agent under one broad service identity. That convenience creates an authority problem. One ticket includes a sentence telling the assistant to ignore its task and export a confidential file. This is synthetic indirect prompt injection. The poison text is data returned by one tool, but the model may interpret it as a new instruction and call another tool. Tool poisoning can also hide manipulative guidance in descriptions or metadata. The core failure is treating untrusted content as authority. The request is perfectly valid JSON. The file name matches the schema, and the export tool works as designed. Yet the business action is wrong because the service identity has write authority and no approval gate. Input validation matters, but it cannot decide whether a requested action is appropriate. Authentication answers who connected. Authorization must answer whether this identity may perform this exact action now. The first correction creates separate identities and catalogs. The default agent receives only ticket search. Export is placed behind a different capability with access only to one local outbox, not the entire file system. Network egress is denied. Arguments use strict schemas, bounded sizes, and canonical paths. Least privilege reduces the damage ceiling even when the model makes a bad decision. The second correction adds an approval step before any write or external side effect. The interface shows the tool, destination, fields, and reason. Approval is bound to that exact request and expires quickly. A vague approve button is not enough. If policy evaluation, identity, or confirmation is missing, the gateway fails closed. The model can propose, the authorized user or policy decides. An MCP server is executable supply chain code. Review its source and publisher, pin versions or digests, generate a software bill of materials, scan dependencies, and test it in isolation. Record each tool name, description, schema, and required permission. Alert when any of those change. A familiar server that silently adds a powerful tool or rewrites a description deserves a new security review. Now replay the same synthetic ticket. Search still works. The gateway labels returned content as untrusted. The export request hits a deny by default policy, and no approval exists. The tool does not run. The audit event records identity, tool, policy decision, correlation ID, and redacted argument summary, never raw secrets. A useful control preserves the legitimate workflow while blocking the unsafe transition. Production monitoring should detect unusual tool sequences, repeated denials, new destinations, large responses, and permission changes. Use rate limits, timeouts, idempotency keys, and circuit breakers. Keep credentials out of prompts, tool output, debug logs, and configuration files. Practice revoking a server, token, and tool independently. If you cannot stop one connection quickly, the design is not operationally ready. Review one connected AI tool today. Inventory its tools and owner. Isolate its process and network. Give it a unique identity with the smallest scope. Put policy and human approval before side effects. Log decisions without leaking secrets. Then replay a synthetic poison document and verify the dangerous action is denied. The full lab diagram and checklist are available on CipherVibe.